Hi. In our last video, we built a simple MCP architecture for an agent's communication with external tools. But the real power of AI is in teamwork based on collaboration of multiple specialized agents. So in this video, we decided to discuss inter-agent communication and collaboration while building a simple AI workforce to handle a common business problem. In a customer service AI assistant system, a customer wants to cancel an order. We'll architect the production ready solution piece by piece. Okay, so here's our scenario. A user sends a request to a web agent saying, please cancel my last order and provide refund. The web agent does every single thing from understanding about the customer request, parsing the request, understanding what logic to apply, what tool to reach out to be able to process this refund or determine whether the customer is eligible for the refund, and then response to the customer. What's wrong with it? There's a huge problem with this single agent system that it's a single point of failure. What if this web agent fails? The second problem is specialization. This web agent does every single thing. There's no separation of concerns. There's no specialization involved here. To solve these problems, we have multi-agent systems. And let me show you. Okay, so this is our multi-agent system with different agents like billing, product, and so on. So when the user sends the request to the web agent, please cancel my last order and provide refund, the web agent immediately recognizes the intent. On the basis of that intent, in our case, canceling the order and providing refund, it determines which agent to call. In our case, that would be billing agent. Now the web agent here does two things simultaneously. One, it acts as a conversation agent with the user, keeping the user engaged with small talk, with response related to the orders that I'm working on it, etc. At the same time, it sends requests to the billing agent. How? So when the user sends a request to the web agent, it immediately creates something called a session detail. That session detail includes something called a session ID that determines all the conversation that has happened with the user in this particular session. This session details could be in the form of customer context, customer details, as well as request details. And this includes session ID, as I said. This entire request is sent to the billing agent with a proper format that the billing agent needs. This session detail is also saved in something called a session memory. We'll talk about the memory later, but just to give you some idea of where it's saved. Now, as the request is sent to the billing agent could be occupied, the billing agent could be crashed. This direct call to the billing agent is not the right way in 2025 to send a request to a different agent or communicate between two agents. To solve the problem of direct calls, which is single point of failure, which is what if there are multiple requests and they're taking time, how will the web agent react if the billing agent is taking a long time? The third problem is, what if the billing agent crashes? The web agent will not be able to solve the problem of the user. To solve these problems, there's something known as the message queue. Let's talk about it. This message queue acts as a postal agent between the two agents for the communication. How does it help? So when the agent creates something called a formatted message to the billing agent, it sends the message to this queue and forgets about it. Now this message queue stores the message from the web agent. So in the case when one of those two agents crashes, or if there's another agent that joins a conversation, the message is still preserved within the message queue. This acts as a fault tolerance or reliability part of our application, which is a big part of any scalable application. The billing agent accepts requests one by one from the message queue from different agents. In our case, this is our particular request from this web agent. So how would this billing agent determine that this request was sent by this particular agent about this customer? There's something known as a correlation ID that is used alongside session ID that we discussed earlier within this message. This correlation ID helps the billing agent determines which web agent or which message it corresponds to. Now, this billing agent does 5 things. 1. It gets message from the message queue and parses it. Second, it determines what exactly is the request from the web agent and what data it needs for that to solve that request. For that, it uses one of the 3 memories. It could be a working memory. So working memory is essentially corresponding to every single agent. So web agent has its own working memory. Billing agent has its own working memory. Working memory is nothing but a very short-term memory. It could last up to 30 minutes. Working memory is usually stored in your languages variables, like for example JavaScript variables and so on. Session memory is something that we already discussed. It is pertaining to a particular session. In this case, this entire conversation could be considered a session. It lasts from somewhere between 30 minutes to 24 hours or even beyond. Then we have something known as persistent memory. It is usually stored in a relational database like PostgreSQL to store long-term details. In our example, it could store something like long-term behavior of the user, standing of the user, whether the user is a premium user or not, how many refunds they have requested in the past 1 month, 2 months, and so on. Working memory, as I said, is stored in the language, the variables of the language. Session memory is usually stored by something, could be Redis, something like a key value database like Redis and so on. Why we need key value database for session memory is because the key would be the session ID and it would have all the variables corresponding to that particular session, like request details and customer conversation, context details, and so on. Once the billing agent grabs all the session memory and persistent memory that it needs to determine whether this customer and the request is eligible for a refund or not, third thing that it does is it would solve the problem using any external tools. For example, it would use payment APIs, for example, some external APIs to be able to process the refund using model context protocol or MCP servers and so on. Last thing that the billing agent does is it processes the payment if it's successful or not. If it's not eligible, it would write it back and responds back to the web agent through another queue known as response queue. So this response to the web agent could include payment details, logistic details like how long will it take for the request to process. It could contain other details like this customer is a premium customer, please take care of them or provide a $5 coupon and so on. So basically provides further guideline to the web agent on the basis of the entire business logic. Here there is a separation of a specialization or the duties between the two agents. Although both web agent and billing agent have access to the message queues or the response queues, they have access to all 3 types of memory: working memory for each agent, session memory, persistent memory. Even then, the web agent is primarily responsible for parsing the request from the customer, understanding the user intent or their temperament, their sentiment, and so on. It's responsible to use one of the other specialized agents to be able to solve it, but it doesn't contain any business logic or any logic to process the customer request. That responsibility lies with the billing agent. Both of these agents persist their memories into session memory or persistent memory. For example, when the billing agent processed everything, it stored its working memory back into the session memory, as well as whatever was needed to be persist in the persistent memory. This session memory was picked up by the web agent that, okay, this is what is the past conversation through all the agents in this particular session. So the web agent has both the message from the billing agent and the session memory stored or persisted by the billing agent and any other agent in the past within the same session. Now the web agent will again parse the answer, uses all the information to reply to the user that, okay, your request was processed or not processed. Unfortunately, it wasn't successful. Or if it was successful, and a goodwill gesture or small talk. This example shows how message queues work, how different memory types work, and how our agents collaborate. It's a very simple example to show these concepts. And that's how AI agents actually work together in production. We've gone from simple tool connections to a full collaborative system with message queues, memory management, and specialized agents working together as a team. In our next video, we'll discuss infrastructure and production related elements like error handling, monitoring, and scaling strategies. If this video helped you understand agent collaboration, please let me know in the comments what other topic I should cover. See you in the next one.